So today, bless you, I'm going to cover complex numbers. Okay. So complex numbers, it kind of revolves around the number I. Okay. So I, they say it stands for imaginary, but you can't really say it stands for imaginary because in engineering they don't use I, they use J, so we just really use it to describe complex numbers. Okay, so the imaginary number I is defined, well, not by, but as I equals square root of -1. Okay. Now if you square both sides, you get I squared equals the square root of -1 squared. Remember, the square and the square root cancel each other out. That means that I squared equals -1. Okay, so the two main ideas of complex numbers revolve around those two equations. Thank you. Okay, so let's say, for example, then you have to remember. Excuse me. Yep, not high enough. That the nth root of a times b equals the nth root of a times the nth root of b. Okay, so this is how we're going to simplify the first round of complex problems or complex terms. All right, so let's say, for example, say you want to write each term or each expression in terms of I. Okay, so let's say for problem A, we have square root of -9. Say for problem B, square root of -7. Say for problem C, the negative square root of -18. And for problem D, let's make that the square root of -24/49. Okay. So for problem A, if you have square root of -9, you can make that square root of -1 times 9. And of course, you can just separate it when you're multiplying. So that's square root of -1 times square root of 9. Square root of -1 is I, so we go ahead and replace that. And square root of 9 is 3. But mostly, you put the coefficient first, and then you put the I second. If you put it as I3, it's the same thing. But it's more commonly written like that. All right, so any questions on that one? Okay, so let's say for problem B, do the same thing. square root of negative 7 is going to equal the square root of negative 1 times 7. And if we go ahead and separate those two, square root of negative 1 times square root of 7. Okay. Now for this one, we can make square root of negative 1 just I. But square root of 7 kind of stays square root of 7. So you can make it square root of 7 I. Okay. Now the same thing for C. The negative square root of negative 18. Okay, so we just have to remember that 18 is equal to 9 times 2. Okay, so we can actually make that, remember that negative is on the outside, let's make that square root of negative 1 times 18, but we'll make that negative 1 times 9 times 2. Okay, and we can just go ahead and separate all three. Negative square root of negative 1 times square root of 9 times square root of 2. Okay. Now the square root of negative 1, of course, we can just make that I. And I'll just make that negative I. Square root of 9 is 3. I'll make that, or put it that way, times 3. And you just have square root of 2. So if you wanted to rewrite that one, it's most commonly probably square root of negative 3, square root of 2i. But if you wrote it in a different order, it's still the same thing because it's all multiplication. Okay, and for D, do the same thing. Okay, so if we have square root of negative 24 over 49, you can rewrite that as square root of negative 1 times 24 over 49. Okay, so that means you can break that apart. Make that square root of negative 1. Oh, there we go. Times the square root of 24 over 49. Okay, a square root of negative 1, we can just make that I. Times and square root of 24 over 49. Remember, we can make that square root of 24 over square root of 49. Okay, so remember square root of 24 is, to have a square root, you can make it 4 times 6. You could use 8 times 3, but 8 isn't a perfect square, so you want to pick 4 and 6. Okay, so we know that 24 equals 4 times 6. So that's going to equal, should have enough room to finish that on here. Square root of 4. Actually, I'll make it 4 times 6 here since we're limited on space. Times 6 divided by square root of 49 is 7. And don't forget our I. Okay, so that should equal, square root of 4 is 2. So you have 2 square root of 6 over 7 I. And barely made it. All right, so any questions on that one? All right. Let's leave that up for a few seconds. All right. So really, you don't have to go through the step of separating and everything else. So if you have, let's say, in general, for a positive real number, that we'll call that real number b. The square root of negative b, you can just make that I square root of b, or square root of bi. So whenever you see a negative on the inside, you can just go ahead and factor out the negative and make it I. All right, so we'll have the complex form, so a complex number is any number that can be written in the form a plus bi. Where a and b are real numbers. And I is equal to the square root of negative 1. Okay, so let's say, let me see. Just a quick note. For a plus bi, the a is the real part, and the b is what they call the imaginary part. Oop, forgot my parentheses there. Okay, so for example, if we have so you have 2 plus 11i. Okay, your 2 will be your real part. Let me clean that up a little bit. So a would equal 2. And this would be your imaginary part. So your b would equal 11. Okay. So what if you had, kind of separate that a little bit, 6 minus 9i. Okay. So for this one, your a equals 6 is your real part. For this one, your b would equal negative 9. Because remember, it's a plus bi. So that would actually be plus negative 9i. So negative 9 is your imaginary part. Oops. Okay. So what if you, actually let me write that below it, since I'm running out of room. What if you have negative 1/2? Actually, you can write that as a complex number, because you can just make that negative 1/2 plus 0i. Okay, where in this case, your a equals negative 1/2 is your real part, and your b equals 0 is your imaginary part. Okay, so you can do the exact same thing if you had let's say just square root of 3i. Remember that I goes on the outside of the square root. Okay, you can actually rewrite it as 0 plus square root of 3i. Okay, where in this case, your a equals 0, that's your real part, and your b equals square root of 3, that's your imaginary part. All right, so any questions on that so far? All right. Oops. Oh, let's see if anyone's still writing. Looks like everyone's done. Okay, so let's say, for example, you want to write each number in the form a plus bi. Okay, so let's say for problem A, we have just the number 6. Okay, so let's say for problem B, we have square root of negative 64. And let's say for problem C, we have negative 2 plus square root of negative 63. Okay. So for any just number by itself, that's going to be your real part. Okay. So for A, if you have 6, you can just write that as 6 plus 0i. And it will be in complex form. Okay. So for B, remember, square root of negative 64, if you wanted to, you can make it negative 1 times 64 and then break them apart. But whenever you have that number there, you already know that's just going to be square root of 64i, or I square root of 64. So you can kind of skip the breaking apart section if you want to. I mean, if it helps you, you can still use it, but you don't have to. Okay, so we know square root of 64 is 8. So we end up with 8i. So let me circle the final answer. Oh, it's not the final answer because we didn't put it in complex form. Okay, so this would be 8i, but in complex form, it will be 0 plus 8i. All right, any questions on that so far? All right, and for C, we have negative 2 plus square root of negative 63. You can actually just write that. Since it's negative, we can just pull it out and make it an I. Negative 2 plus square root of 63i. Okay, so now we can simplify the 63. So for 63, you have a perfect square of 9. So you have 9 times 7. Okay. 63 equals 9 times 7. So that gives us negative 2 plus square root of 9 times 7. Well, I might as well go ahead and separate them now. Square root of 9 times square root of 7, I. Square root of 9 is 3. That gives you negative 2 plus 3. Square root of 7 is square root of 7. You can leave that the way it is. It's not a perfect square. And your I. All right. So any questions on any of those? All right. Okay. So now we're going to start to add, subtract, multiply, and divide complex numbers. Now, adding and subtracting, you're going to do that the same way you would add and subtract variables. You just add their coefficients. Oh, anyone's still writing? Yep. All right. Adding and subtracting. Complex numbers. Okay. So the first, well, I guess you can call it steps. Okay, so the first thing you want is you want it to be in A plus BI form. So all terms should be in the form of a real or imaginary number. Okay, so that means any square root of negative numbers, you want to make that the square root of that number I. Okay, so instead of negative square roots, you just want i's. Okay, and 2, you want to either add or subtract. Uh-oh. The real parts with the real parts and the imaginary parts with the imaginary parts. And imaginary parts to imaginary. Okay. Now remind you that I is not a variable, it's an actual number, but we treat it like a variable when we're adding and subtracting. I is not a variable, but we treat it like one. When we are adding or subtracting. All right, so I'll leave that showing. Let's say, for example, if we wanted to add 8 plus 4i plus 12 plus 8i. Okay. So you would do that the same way if you had 8 plus 4x plus 12 plus 8x. Okay, so you get rid of your parentheses, which since they're all adding, it's just 8 plus 4i plus 12 plus 8i. Okay, so you add your imaginary parts and you add your real parts. Okay, so 8 and 12 is 20. 8 and 4 is 12. Okay, so just like you would if it was a variable. Okay, so let's say if we have, separate that one. You wanted to add, well, subtract rather, this one. Say -6 And drop that down a little bit so it's not as close to the previous one. Negative 6 plus 4i minus 3 plus 2i. Alright, so just like if you had a variable there, you'd have to distribute the negative. Okay, so you have negative 6 plus 4i minus 3 minus 2i. And again, you're going to add your imaginary, and you're going to add your real. Okay, so negative 6 minus 3 is negative 9, and 4i minus 2i is positive 2i. Okay, so for those two, you didn't have to do step 1. They were already in real or imaginary form. But for this one, you would have to convert it first. Okay, so let's say, for example, you have 7 minus square root of negative 16 plus 9 plus square root of negative 4. Okay, so the other one already had i's. This one, you have to convert it to have the i's. Okay, so you have 7 minus negative square root of 16. You can just make that square root of 16i. Of course, you can make it 4, but I don't want to skip steps. Square root of 16i plus 9 plus square root of 4i. Okay. And then from there, you just simplify it. And I'll start this one over here. Separate that a little bit. Okay, so you have 7 minus square root of 16 is 4, minus 4i plus 9. Square root of 4 is 2, so that gives us plus 2i. Then we combine the reals with the reals and the imaginaries with the imaginaries. So we combine the 7 and 9, and we go combine the 4i, negative 4i, and 2i. So you have your imaginaries and you have your reals. Okay, so 7 and 9 is 16. 4i, negative 4i plus 2i is negative 2i. All right, so any questions on that one? All right. Oops, I'm still writing. Okay. Oh, we're at 29-ish. We'll probably be cutting off in a second.